What's going on, guys? Today we're doing an 80 millimeter MAF housing. The stock MAF was only like 62 millimeters, 60 millimeters, considerably smaller, but it does have its limitations as far as how much power it can handle. And I believe the number is somewhere around 260, 240 is what this thing can handle. I've got it wrote down somewhere as far as what this MAF can actually handle. But anyways, primarily what we're going to be going over is what it takes to swap a MAF. This particular MAF came out of I want to say it was an 02 f250. Nearly the same part number as a GT out of a 4.6 Mustang or out of a Crown Victoria. A lot better unit though. It flows a lot better, get a lot more air through it, which is what we're trying to do. I want to get this set up first, make sure that this MAF is going to fit, function, and it's going to operate, it's going to read correctly, and get this dialed in before I install the turbo. And the reason for that is that I want to eliminate any issues that this might have or any tuning parameters that need to change specifically because of this and the rest of the setup on the car before I install that turbo, because if you don't, you've got a lot more issues that are now in the system, because now you have a forced induction, you've got a different MAF, you've got different injectors, so you've got all these problems start adding up very rapidly, and all of a sudden you have no idea, you're not really seeing any differences and any changes you're making. So this is basically to eliminate all that, try to resolve issues one at a time as we go. So we want the MAF sensor installed before we do the turbo, and we want the injectors done before we do the turbo, which we've got those 42-pound injectors. Should be seeing another video on this week. I might just start calling this the spouseless week, something along those lines. Basically, the wife's gone this week. She's down visiting in-laws. She had some time off work, going on kind of a small tour. Go see a whole bunch of different family members she hasn't seen in a while. I wasn't able to go. I got to work, but this means my evenings are free. I can actually work on some projects. So you guys should be seeing a lot of videos. But primarily today, we're focusing on this MAF sensor swap. We already pulled out the stock one, which I'll show you. And mind you, this K&N filter that's on here, this was cleaned about 2 months ago. And as you can see, it is already plugged up. That being said, they have been hauling a lot of hay up and down the roads, especially the highways that I drive down, but there is a lot of crap picked up in this. One thing to remember, if you have a K&N style filter, just because you have a high flow filter doesn't mean that it's flowing any air if it hasn't been cleaned. Like if, for instance, that one had been on the Mustang since... It was on there when I bought it. I cleaned it when I first bought the car, cleaned it out, dried it out, re-oiled it, and then I didn't touch it for about probably 5 years. I could not believe how nasty it was. Again, that's only been 2 months with that on there, and that filter's that plugged up. And it was originally a nice, beautiful red color like this. This is a Summit Racing unit. This is... pretty cheap, actually. I think this was like 20 bucks. But it has the flow through in the center, and it has the flow on the outsides, which some dyno testing has shown that this style does a lot better. Whether or not this particular one will, it's up in the air. But yeah, I don't know that there's necessarily a reason to go with a real high-end filter. At the end of the day, it is still just an oil filter. I mean, it catches a ton of debris. They plug up. If you over oil them, you can contaminate and destroy MAF sensors. That's one of the most common problems I see people bringing cars in. Oh, hey, I just cleaned my K&N. Car won't run worth a crap now. Don't know what's wrong. And then I pull the MAF out, and it's completely just soaked in oil. And then I'll end up having to take a blowgun, some compressed air, try to blow all that extra oil that they just soaked the filter and out. And normally they end up having to replace the MAF sensor, and I'd say about 50% of the time the customer goes, you know what, just throw that thing away, let's get a brand new one installed on it. Just screw cleaning it, it's not worth it. Which for the price of these that you can find them, that's pretty stinking cheap. 20 bucks for that. I mean, you'll pay that for an OEM filter. Even some at, you know, AutoZone that you think, oh, they'll be a little bit cheaper on filters. Now they're about 20 bucks nowadays. So for the price, might as well replace them. But anyways, this one's getting a brand new one. This MAF housing, or the adapter that I've got on here, was off of a stock GT Mustang or off the F250. It'll work the same, but this basically just gives you a way to bolt the MAF up and then be able to slide a filter on. Now, I was going to build one of these. I've still got it drawn out on a piece of steel, ready to cut out and then form and weld up and clean up and paint and make look all pretty, but haven't got to it yet. And it's not necessarily mandatory at this point, so this is going to go in, it's going to fit, it's going to do what we need it to, and it should function. Now, the part number on this, what you're looking for when you're in the junkyard is this right here, because some Fords had an 80 millimeter MAF and some didn't, and it just depends on the year. So if you're looking at Crown Victorias, a lot of those did not have 80 millimeter MAFs. A lot of them did, and they're very specific years. You can get on the internet and search. Good luck. I struggled. I was finally able to find information for this one, because go figure, I couldn't find a GT Mustang in the junkyard with a MAF sensor in it that hadn't already been taken. Found plenty of GTs, but no MAF sensors to go with them. So the F250 will work. It would be better to buy this as a brand new unit, but if you're going to go buy a brand new MAF, might as well upgrade it just a little bit better than a stock GT. But this will flow the air, and will read the air that we're trying to flow for the power numbers we're trying to hit with the turbo. So what you need to do is that the GT and the F250s, F150s, Crown Victorias, they used an external intake air temperature sensor is what it's called, which I think I've got mine laying here somewhere. There's the harness connector, but it's basically a 2-wire sensor that reads intake air temperatures. And where you place this is going to make a significant difference. And of course, now I can't find it. Set it down for 2 seconds and you lose it every time. That's how that works. Anyway, so it uses a separate intake air temperature sensor. Very easy to find. They're always in the intake track somewhere, usually before the throttle body. But anyways, you need that intake air temperature sensor. And throughout the years, there were a little bit of changes for the data for the intake air temperature sensor as far as tuning it. But for the most part, they're all the same. They're pretty close. I mean, you might need to make a couple of minor adjustments. And of course, I don't have it written down in here. Because when I researched it and started doing, trying to figure out exactly what the intake air temperature parameters were in order to swap it, they were so similar that it was within like a degree or two with the voltages, and we're talking within like tenths of a volt, or not tenths, hundredths of a volt. So it was such a minor change that I'm going to run it as it is, and if I need to make changes, we definitely can. Very simple to do. But for now, what I've got to do is I've got to drill a hole somewhere in the intake. Now, the MAF sensor has to be in a straight path, so the straighter the path is for the longer time, the better off you're going to be. So we are obviously having to make a pretty rapid corner here, but we do have a little bit of straight after the MAF, which is going to help us a little bit. But you want what's called laminar flow. You want that airflow flowing straight through that MAF. You don't want that air coming around a corner and bouncing like this and then have the MAF up here. It's going to be reading junk every time. It's not going to be reading accurately, and it's going to be wrong. You're going to have a hell of a time getting that thing to run right. It can be done, but you're nowhere even near where you should be on accuracy on the MAF sensor, especially because this is a MAF sensor car. This is really one of the #1 key reasons why an engine will either run rough or not run right at all. And that's because it heavily relies on the readings from the sensor to know how much fuel to add. Now, it does have oxygen sensors that can say, hey, we're running a little bit rich. Hey, why don't we just dial that fuel right back? Or, put a little bit more fuel in. We're running lean here. I mean, the MAF can make some corrections, usually about 15% in either way. Before it will throw a code on these older systems. Newer cars, anything over about 7% fuel correction in either direction indicates that there's a serious problem. As far as like a vacuum leak or a leaking injector or whatever the cause may be. But this sensor is key to everything. And without a good functioning MAF, that the engine control module is, I mean, he's clueless. He has no idea what to do. He does have some alpha N's, which I don't want to get too far into the tuning parameters and tuning terminology, but alpha N is basically a backup in case the MAF fails so that the engine can still operate, it can still get down the road, not with the power that it was ever supposed to have, but it can somewhat run. And basically what it is it's the alpha N is a calculation that's done by the ECM that uses inputs such as the total engine cubic inches, and then calculates as far as, and it also needs intake manifold parameters. It needs to know in what size intake is going into it for it to function correctly. I mean, there's a lot of stuff that factors into alpha N, the correct injectors, correct MAF sensor. For the most part, you don't really ever touch it. You kind of, if you're in alpha N, you've already messed up. You're not trying to change things around an alpha N in that equation. What you're trying to do is actually stay out of alpha N. But it is a fail-safe. So if you do this and it's running like crap, the one way to know if you're in that alpha mode, that fail-safe mode, is that what it will do is your instrument display will go blank. It'll just blank out, and then you'll get dots start coming across, straight lines, and then it will kind of hesitate. You'll feel it in the engine. The engine will kind of stutter down, kind of rev up a little bit, stutter down. But that's it actually entering that alpha N mode. And when it does that, you'll know it because it'll be wicked down on power. And when that happens, you know you've done something wrong. More than likely in the tune. If you're using a junkyard MAF, that is number one, probably what's wrong with it. But it could still be tuning issues before you condemn it. But yeah, one thing to watch out for is that alpha N when you're doing tuning like this. But we are going to be swapping to an 80mm MAF. We have a quarter horse tuning chip installed. This is from motes.net. Great people, great product, absolutely love it. But basically it gives you full control over everything. So we're going to be changing MAF sensor data, which I'll show you that here real quick. The MAF sensor data, let's see if I can get back to it. There we go, F150 and F250 stock MAF sensor, and I apologize. You guys are probably not going to be able to read this, but that's the website you want, is efidinotuning.com. A little bit of a different website, like you kind of got to play around with it a little bit to really figure out how it works. But they have a whole bunch of just stock MAF sensors and aftermarket MAF sensors, and everything you need to be able to convert it. So this is the way they give it to you, which you have to do a conversion, kilograms an hour to pounds a minute, before you input this into your ECM. Some ECMs are actually running on kilograms an hour. Again, that is the metric system, which, okay, let's be honest, it's more accurate. And that's the reason that they use the kilograms an hour, is that it is a lot more accurate method of measuring. But here you can see at 16 volts, which is something we should never see. You can see this is kilograms per hour, and then it goes down for whatever MAF sensor reading. So as that MAF wire has a 12-volt input, and it has a 5-volt reference input. Actually, I've got the diagram, or the pins. So we have intake air return, power hot, that's 12 volts in, 3 MAF ground, 4 MAF return, so that's the wire that actually sends that, and then the 5 volt is the PCM to MAF reference 5 volts. So what that means is that that's the reference voltage, the PCM sending 5 volts in, and then it's sending whatever sensor is reading back down terminal 4 for the MAF return. So as more air comes across that sensor, it has to heat up even more, so it requires more voltage. And as the voltage goes up, this is what it says. Okay, so we're seeing 3.25 volts. which means we've got about 344.4 kilograms an hour. We're going to factor that out to about 12.65 pounds of air per minute, and then add fuel accordingly at whatever the requested fuel is at the time, which for all intents and purposes, to make it easy, we'll just go 14.7. Let's say we're commanding a very, it's a heavy load, but we're still commanding 14.7 volts. We're not in wide open throttle. So 3.25 volts, it's saying 344 kilograms of air. We need 14.7 parts of that air for every 1 part of fuel. So the ECM calculates that and it knows exactly how much fuel to inject. And then let's say you accelerate just ever so slightly, step on it, get a little bit more air flowing. Okay, hey, we've increased airflow, increased injectors. And the ECM is doing this quicker than you could ever imagine. This is doing this thousands of times per minute. It is factoring, calculating, and reevaluating, and then outputting parameters, outputting fuel to the injector, saying, hey, I want this much fuel, I want this much time dwell on, this much time open. And then it reads everything back from the oxygen sensors and then comes back to this. And goes, okay, so at 3.25, for example, we're at a medium load, crawling up a hill, and we're still running just a little bit lean at this. So we're going to add just a touch more fuel to this. And then it goes, okay, hey, you know what? That was perfect. We got right back to where we wanted to be. We're back to 14.7. And so the ECM will actually save that correction. So it says, okay, well, we're going to save that additional fueling. Let's say it was 5% fuel. We're going to save that 5% fuel at this low, or at this much airflow at X amount of load over here. And it does that. And that's how it does its learning. So if this isn't accurate, it can throw you way off. So like I was saying, there are corrections that the ECM can do. So, but you'll notice just 3 little tenths of a volt or 0.25 volts. I mean, that's a pretty significant jump in kilograms an hour. That's 60 kilograms an hour. And if your voltage is way off, so I think I've actually might even have the stock V6 MAF wrote down somewhere. I don't think I wrote it down. Nope, I didn't. But there's a big difference in what these voltages mean. So these voltages are specifically for that 5.4 liter Triton V8, the 5.4 Triton. These will not be 100% accurate for use on anything else, but they will get you somewhere close, which is where we're going to be starting. I'm expecting to see some pretty massive fueling changes once we install this and update these parameters. I'm expecting the ECM probably to be flipping out. It's probably not going to want to run right. Probably it might idle. I doubt it. But we've got a lot of tuning that we can do to try to even all this out. So what you need to do, if you're not planning on tuning this, this is really not the mod to be doing, because you can really mess up some things, and it's not going to run right if you just slap this in. But if you have a tuner, or you're doing a mail-in tune, whatever, and you can talk to your tuner and get him to update your tune for you, this is what you need to do on your end as far as installing it. Obviously, you need the MAF, you need some kind of an air filter for it, which, I mean, you technically could probably use the stock. I don't know why you would, but and then you need, I ended up grabbing one of these from the junkyard. This is a MAF. This one was actually off of V6. The nice thing is that every Ford that uses this style MAF just almost exclusively has the same wiring diagram. Now, we'll take you back over here to the diagram, show you what's going on here. Ignore all my scribbles, my horrible notes. You can Google this. Obviously, I've wrote this one down, but you can Google this, MAF sensor connectors for the Fords, and this is what they look like. This is what plugs in. The GTs, which is down here, only uses the center 4 pins. It does not use those outer 2. The outer 2 are for that intake air temperature sensor, which is what I was talking about earlier, which is going to connect to here. So what I've done is I've come back here, I've cut these both off. These are both the intake air return and the intake air temperature in. So wait, in, return. It always throws me for a loop. IAT, intake air temperature. But basically what I did is I cut these wires off, matched them up to the intake air temperature sensor, which this one wire is green with a red stripe, and the other one is a solid green. And this is red with a green stripe and green. Now, I looked up the diagrams on a lot of different Fords to try to see what their different wiring was for these. And they're all mostly the same and about the same year span of the Mustang. Anywhere from early 90s to I think 2004 before they changed to a different style math. These are all very, very similar. And all it is just a resistor inside of here, a temperature, let me see if I can say this right, negative coefficient temperature sending unit. It's technically what it's called, but it's basically just a resistor. As it heats up, it lets more voltage through. As it cools down, it'll let less voltage through, or vice versa, depending on which way it goes. But it's only a 2-wire, so you can't really screw it up because it's just resistance is all it's reading. And it doesn't matter which way it's reading it, it's going to read the same resistance. So I could be wrong on that. We're going to find out. Hopefully we don't fry the ECM, but sometimes you just got to roll the dice when there's no information out there. But anyways, what I did is I cut those 2 wires, and then because this is going down inside of that passenger in front of the wheel well and back down below the headlight, I have to bring that intake air temperature sensor back up and out. Now, I want the intake air temperature sensor reading on the back side of the intercooler so that I know the actual temperature that's going into the engine, if that makes sense. Not the intake air that the air filter seeing, because that doesn't mean anything to the engine. I want to see the actual intake air charge temperature that's coming into the engine from the turbo. So it's been compressed, it's been smushed and smashed and squeezed down and ready to get stuffed into that engine, and then run through that intercooler to drop the temperature significantly, and then come out of there. That's where I want to read it, is on that side of the intake. So the pressurized side. But basically what I did was cut the wires and then routed them back. This one, obviously I screwed up. I should have cut it and then pulled it through this rubber boot, which is what I did with the other one. You can see it's cut off and it's up in here. But basically what I did was reconnected to these, and I used those nice soldering connectors, the see-through with the silicone on either end and a nice silver ring. These go so easy. I mean, they're a little on the pricier side compared to solder maybe, but with the time you save, they're worth every penny. But anyways, just routed the wires back up to the original connector, taped it all up, and then continued to route it for as far as I'm hoping is all I'll need. It's probably even a little bit too long, but what we're going to do is we're going to stuff this back down in. This adapter plate, I have pulled this out of the junkyard. It was someone's cold air intake, and it was like the last piece that was left of it. Someone had already robbed it off of it. Didn't end up charging me a whole lot for it, though. So we're going to stick this MAF sensor connector down in here. I'm going to drop that whole thing right down in there. Now this new intake air temperature sensor connector that has never ever belonged to this car, we're going to go through the hole and try to route up through that hole and get the room without kinking all this off of here. This might get interesting. This might take a minute. Hey, wow, we got lucky with that one. You see that? Just popped right out of there. It never happens. You guys must be lucky. We'll never get that lucky. Then we're going to just carefully feed this back up through. Okay, we're getting up there. Now, of course, the other end of the connector is going to try to get caught on any possible little edge or anything that it possibly can. That's just working on a car. Murphy's always going to find a way to get you, so he got me this time. That end of the MAF sensor is hooked on, what is that? Oh, and wonderfully hooked on the wheel well. Wow, it even managed to find its way through a hole and around a metal line. That was rather quite impressive there, Murphy. Hey, there it goes. We're just going to keep feeding this back up until we get this connector end. Hey, sexy, where you been hiding all this time? So this, notice my one-handed connector skills. This is the kind of stuff you learn working on newer cars. You have to learn how to do it blind and one-handed. Click. We're going to stuff him back in there. But that was the stock math sensor connector. So now we've got that other math connector, the new one, down in the hole and ready for us to go. So now comes the fun part. Trying to stuff that guy up the wheel hole, out through that hole, plug in that math, and then reconnect the intake back up to there. Overall, really not difficult to do. As far as swapping it out, the difficult part is the tuning part, which we'll get into that here. Watch for a part 2 on this. We're going to go over some math tuning. And basically, I'm predicting that you guys are going to watch what I'm doing and just laugh at me. Don't want to hurt my feelings at all. I'm not insecure about my gender or anything else. So, I mean, feel free to call me whatever you want, you know, idiot, stupid, whatever. But this is what we're doing. This is what's going down. Watch for that part 2. Should be coming your way here pretty quick. I'm super excited. We're getting a whole lot done because we don't have a boss around here, at least for a week. Don't tell her I said that, please. Please, please, please don't tell her. Life's doing excellent. It's flowing and it's going. We're almost through this 2020. Have a great night, guys.